Where's the problem in your project?
Welcome to the Hello World Show. I'm Spencer Schneidenbach.
I'm Heather Downing.
And today we have Preston Chandler, the Agile and Process Master at VML.
Thanks, guys.
Thanks so much for
coming on.
Did you want me to introduce myself?
Yeah, go ahead and
Okay. So, currently I do work at VML. I do a lot of Agile things at VML. Throughout my career, I have focused mainly on lean management and lean manufacturing and Agile and process improvement and all that kind of stuff. I did my first Agile project about 11 years ago, which was quite early on in the Agile world. Not a whole lot of people were doing it back then. And then I completely departed from it and did not do Agile again for another 7 years. So it's only been in the last several years that I've gotten back into it. And I have a blast doing a bunch of Agile things at VML, leading that practice and leading thought leadership and all that kind of stuff. So
nice.
It's great.
What are you going to teach us? At least something in like 5 minutes or so.
So I'm going to talk to you today about signal versus noise. So my preface is that I am not an acoustics engineer or anything like that. I have just a very basic understanding, but I'm going to apply signal to noise in terms of process improvement. And I think one thing that most developers might overlook is the fact that they are always focused on process improvement. Everything they do is something to make a process better. And so this should be something that's core to how they think. So before we get started talking about signal and noise, I want to introduce 3 terms that are really common in lean manufacturing, but we typically don't talk about them much on the software side of things. So we're going to talk about Muda, Mura, and Muri.
Sounds like a family.
Yeah, it's kind of a family. They're all different types of waste, and the MU part of that is actually waste. This is Japanese for you. And these different types of waste, this is the actual waste. And then Mura is when something is uneven. And so it's a waste because it's not a constant thing. So this is uneven. And then Muri is when it's overburdened. And overburden might cause a lot of other things to happen. So in a software world, you might see that you have way too much traffic to a site, and that's overburden for the site, and it causes lots of other problems to happen. Mm-hmm. Unevenness would be you don't have anybody show up to the site, and then an hour later everybody shows up to the site. If you could have just had them all do it at about the same time, or if you could have all had them show up, 1 minute after each other, it would have been fine. So, and then waste is all the other little things that are just problematic. So it could be a waste of emotion, or it could be that your code just takes too long, you added too much stuff into your code. It could be that there was stuff in the code that didn't even need to be there to begin with. So, now we're going to talk about signal and noise. So a sound wave often looks something like this. Now there's 2 different components for this sound wave. There's the signal, which is the thing that goes like this, and then there's the noise, which is the thing that goes like this. And when you put them both together, they look like what we typically have. And this is natural. We see this in nature all the time. Things aren't generally smooth. Numbers aren't smooth. History is not smooth. I mean, you have some generalities, but then there's a lot of randomness that happens. When we're looking at process problems, when we're looking at problems that we want to solve, we need to understand what type of a problem are we dealing with. Are we dealing with a signal problem, or are we dealing with a noise problem? So I got an example for you. Aaron's, which is a very large equipment manufacturer, they make a lot of snowblowers. They did a whole lot of improvement in their system. They adopted lean manufacturing probably about 20 years ago now. Their focus in lean manufacturing was on noise. They said all of these little things that are wastes, we're wasting some motion, we need to build a snowblower much better faster, we don't want to have any quality errors in this snowblower. So they were talking almost exclusively about Muda, about driving out those little wastes from their system. They did very, very well at that. But one thing that they found out a bit later is that overburden and unevenness was actually a bigger problem for them. How often or how cyclical is the demand for a snowblower?
Imagine it just goes the winter
Once a
months.
season?
Yeah,
Once a
once-
season,
yeah,
right?
winter months.
Yeah, I mean, November through January, about it. Right after the first snow, everybody wants a snowblower. Are people going to buy snowblowers in July?
Of course not. Not unless they're moving to Antarctica.
Yeah, in the southern hemisphere maybe, but
Right.
Aaron's was focused on the northern hemisphere.
Right.
Their predominant market was here in the United States. And so what was happening to them is that they were ramping up production massively throughout the summer and the fall so that they could meet this winter rush of demand. They had to build up a huge amount of supply to be able to hit that. Now they had improved enough so that they didn't have to build up so much demand. They could build a lot faster and respond to demand, but it was still really, really tough on their system. So there was a lot of overburden happening because everybody was trying to rush throughout the months of August and September and October to make sure that they had enough supply. Unevenness because they would hire a huge number of workforce in the summer and not need them in the winter because they didn't have to build anymore in the winter. They had already been built. And what they finally realized is this unevenness and overburden was actually causing the greatest amount of waste and cost for their company. All of the little things that they've done to try to figure out how to build a snowblower better, yeah, those helped. But in the end, the huge cost was that they had to try to hire half of their workforce every year. Just very painful. So one thing that they did is they said, okay, we're going to counteract this horrible unevenness and we're going to build something other than snowblowers. Well, guess what? There are some other pieces of equipment that you might use in your yard that are similar to snowblowers. Rototillers. Very, very similar. When's the demand for a rototiller?
Summer months.
Summer months, typically in the spring, early spring, when people have to rototill their gardens. So what they found out is that by adding this other product, that was a very similar product, they were able to diversify. And they were able to flatten out all of this unevenness and overburden. And that decision itself made them a whole lot more money and fixed a lot more problems for them than all of the work that they've done before to try to drive out waste from their system. You still have to do both. You can't only focus on signal and ignore noise, but it's very important for you to understand what you're dealing with. So I'm going to erase this real quick, just to show when we have something that is signal, there's a couple different ways that we can deal with it. We can decide to take this stuff and we can fill it into the gap. We can push it off until a later point. We often do this in Agile development because we have a big backlog, and instead of allowing ourselves to completely burn out over the course of a couple of weeks, we try to be very steady throughout the course of a couple of different sprints. Essentially, we take some of this overburden and we put it into a low spot.
Is that like acquiring technical debt? And is that one method of doing that?
Yeah, you might acquire the technical debt and then attack that technical debt at some later point. But the whole point is that you're trying to even this out.
Right.
So there's a lot of things that we might do process-wise in implementing Agile to do that. But I think that this is really intriguing when you start looking at actual development. What can we do in our development process and in our coding that will allow us to make the coding much more even? Things like not requesting all of the data at once and requesting a little bit at a time so we're not overburdening the system by requesting everything at once. But this is a very different response than if we're looking at noise. Noise is always going to be there. You're never going to be able to make noise not occur. It's something that happens in nature. It's randomness. We need to take steps to limit the amount of noise. And so we hope that we can chop off the top and chop off the bottom a little bit, and that I can have something that's a bit more regular, but it's never going to disappear. So we need to look at trying to eliminate sources of noise where possible, But when we're looking at the signal, we want to refine the signal. We want to level that signal out so that it's not nearly as bumpy for us. And again, the type of problem that you're dealing with, if you really understand that, then you'll be able to turn around and apply a very appropriate solution to it. If you try to attack everything as if it is waste and eliminate it, that's wrong. It's not going to help you out. In the case of Aaron's that we talked about, they didn't want to eliminate the production of snowblowers. That's bad. Like, they're making money by these snowblowers. They can't eliminate that. They needed to find some other way to balance their production of snowblowers.
Nice. So it sounds to me like most people are attacking almost like the symptoms instead of the source for most of this. It's like, oh, maybe we need to sell more snowblowers. So, quick, how efficient can we make them so that more people want them? Is actually the wrong motivation then in that case.
Correct. So they're trying to attack a signal with a noise solution.
Interesting. So how would you apply that to like a first or second year developer that is just trying to figure out how to pace themselves with a bunch of work that's coming in, and maybe it's coming in all at once? How would you suggest that they attack organizing that?
I think a lot of it just, it takes a little bit of maturity, and then you grow into that and you start realizing, I need to take a step back. Why is all this work happening? There are certain times when, yeah, you do need to spike. Noise happens. But normally if you take the step back and say, okay, why are you asking for all these things at the same time? Are they really all important? Then you can attack the ones that truly are important and say, yes, this is noise, and the stuff that's not important you can treat as signal. And you can level out that signal and start to educate others that this overburden and the unevenness is not good for them and it's not good for you as a developer. Being able to keep in more of a constant, consistent flow is very important. Something that's a short spike, if you have 1 week where you have to work 50 or 60 hours, okay. If you start seeing that it's several weeks in a row where you're working 50 or 60 hours, it's a great way for you to understand, oh no, this is a signal problem. This wasn't a one-time thing. This is a much larger, it's a systemic issue now instead of some random occurrence.
Thank you for breaking that down for us. It's really fascinating.
Yeah, absolutely. Thank you very much.
Don't forget to share this video on social media.
And comment below to be entered into our weekly giveaway.
Tell us what questions you have for our guests. See you next time.